Welcome back, Union High School Pre-Calc. We hope you are doing well. This is Mrs. Peterson again on behalf of Mrs. Bybee, Miss Miller, and Mr. Thomas and myself. Hope that distance learning is going good. We are on week 3 of distance learning, so I just wanted to kind of give you a heads up of what's coming up this week. We are going to finish sort of this first unit of distance learning today with our area lesson. You'll have some area homework actually on Canvas. It is not going to be on my math lab. So you are going to submit that worksheet through your teacher's preferred mode. It will be either via Canvas or via email. So listen to or keep an eye out for how your teacher wants you to submit that. And then there will be a limits and area review on my math lab. It is just like the test, but with different functions, different numbers. And that, as well as your area worksheet, is going to be, they're both going to be due actually Thursday this week at 9 p.m. instead of Sunday. And the reason for that is because we've got what we're calling a quest. So it's this quiz plus test, and that is going to be open to you on Friday from 8 a.m. to 9 p.m. It will be on my math lab, so it'll be very, very similar to your homework. And again, that review is just like the quest. So, and just like regular homework, you can do that review as many times as you want. And then you'll have from 8 a.m. to 9 p.m. to take the quest. Remember that it goes in both your quiz and test category if it helps you, in neither if it doesn't help you in either, or in just one category if it helps in one but not the other. However, keep in mind that you have to have at least a 75% on your homework, starting with last week's homework, which would be limits algebraically, so limits algebraically and beyond. You have to have at least a 75% on that homework to be eligible to take it, okay, to take that quest. All right, if you have questions on any of this, obviously don't hesitate to ask your teacher. Okay, all right, so for area, we are going to be looking at area under the curve, and this is actually one of the two big questions of calculus. So you've got differential calculus and integral calculus. Differential calculus answers the question how fast. Integral calculus answers the question how much. And you'll look at more of the motivation behind the area under the curve when you get to calculus. Like right now, it's going to seem like a very geometrical question, which it is, but it actually also answers some very deep questions of applications in really every realm, in finance, in physics, and so on. So we are going to be taking a look at this question today. Until we get to calculus, we're not going to have the tools to find the exact area under the curve for most functions. However, we can use algebra to approximate the area under the curve, and it turns out that we need these approximations often in real life because often we're given data points as opposed to this nice continuous function. Okay, so let's take a look at sort of what the big picture of what we're doing today, and then we're going to take a look at some examples. So I've got this function, it's just your standard parabola reflected, so opening down and shifted up 16 units. And if I were to ask you to find in calculus next year the area under the curve from x equals 0 to x equals 4, what I would mean is that. So when we say area under the curve, we're really talking about the area between the curve and the x-axis. Okay, so in calculus, we'll learn how to find that shaded red area. In pre-calc, what we do is we estimate that area using different shapes, typically using rectangles. And we've got different rectangles we could do. So let's say that I wanted to use 4 rectangles, so I'm going from x equals 0 to x equals 4. Let's say I wanted all those rectangles to have the same base. So each rectangle in this case would have a base of 1, okay? Now the height is going to depend on which method I use. Let me show you what 4 rectangles using the left-hand sum would look like. Do you see how I used the left y value there to create the height of each rectangle? Now, would you say, and we call this LRAM, so the left rectangular approximation method, would you say that LRAM overestimates or underestimates the true area. Remember, here's the true area, here's LRAM. In this particular case, LRAM overestimates it, right? Do you know why that is? In this case, it's because the function is decreasing on my current interval. Okay? Now, if I wanted to get a better approximation still using LRAM, I would just want to take more rectangles, right? So see how the more rectangles I take, the better my approximation becomes, right? It's getting closer and closer to the actual approximation. So the more rectangles, the better the approximation. The downfall with more rectangles is what? It's more work, okay? To get the exact area, I would need an infinite number of rectangles, and that's where calculus comes into play, okay? The savior of calculus is infinity. So we will look at how to get the exact area next year. For now, we're going to approximate using a finite number of rectangles, okay? Here is what RRAM would look like. So this would be the right rectangular approximation method. Notice in this case, RRAM is an under approximation of the true area, right? There's the true area. And again, that's because your function's decreasing. In fact, if you take a look at your fourth rectangle, it actually has an area of 0 because the right y value is 0 there. Again, the more rectangles I use, the better the approximation is. However, more rectangles equals more work. Okay. Another approximation method is called MRAM, and that's where I use the middle y value, also known as the midpoint sum, okay? You can see that MRAM is typically a better approximation because you can see, yes, I've got a little area that's over for each rectangle, but I also have a little bit of area that hasn't been covered, okay? So this is an example of MRAM. And then the fourth kind of approximation we're going to do is a trapezoidal sum. And look at that beauty. Look how close that gets you. Okay, so let's try some examples and try to get this more concrete for us here. So I've got this function, f of x. The first thing I want you to do when you're given a graph is to make sure the endpoints are connected to the x-axis. So we're going from 0 to 8. 0 is connected already. I want to connect x equals 8, or f of 8 to the x-axis there. The true area, again, you can see would be all of that, okay? We're going to approximate this area using all 4 methods. So we're going to start with RRAM, the right rectangular approximation method. And in this case, it says use 4 rectangles, and we're going to assume that the rectangles should have equal bases. Okay, so again, my whole length goes from 0 to 8, which is a length of 8, and 8 divided by 4 is 2. So each rectangle is going to have a base of 2. So I'm going to go from 0 to 2, 2 to 4, 4 to 6, 6 to 8. Okay, now since I'm using RRAM, I'm going to pick the right y value. So, for this first interval here, from 0 to 2, the right endpoint would be x equals 2. When x is 2, y looks like it's 2.5, right? So here is my first rectangle. Okay, and notice that rectangle's height is 2.5, base is 2, so it will have an area of 5. Okay, the second rectangle goes from x equals 2 to x equals 4. I don't know if you can hear my son's garbage truck in the background there. The right end value is x equals 4. When x is 4, looks like y is 1. So my second rectangle has an area of 2. All right, third base goes from 4 to 6. The right endpoint is x equals 6. F of 6 is 4. So I'm going to create a rectangle over the interval 4 to 6 with a height of 4. Okay, and that has an area of 8. And then my last rectangle goes from x equals 6 to x equals 8. F of 8 is 1 here. So I've got an area of 2. All right, so I can add all these up to get an approximation. Approximating the area using RRAM and 4 rectangles of equal base will give me an approximation of 17. Okay. All right, so let's try this same function, 4 rectangles again, but this time let's do LRAM, so the left rectangular approximation method. Okay, since it is 4 rectangles still, I'm still going to assume that they should be spaced equally. So we're going to go 0 to 2, 2 to 4, 4 to 6, 6 to 8, but this time I'm going to use my left y value as my height, okay? All right, so this first one, the left x value is 0, and when x is 0, y is 0, so the first rectangle actually has an area of 0. Okay, the second rectangle goes from 2 to 4. The left endpoint is 2. When x is 2, y is 2.5. So this second rectangle has an area of 5. All right, the third rectangle goes from x equals 4 to 6. Here's the left y value. Still the garbage truck there. This rectangle has an area of 2. And then that last rectangle goes from x equals 6 to 8. Here's the left y value, so create a rectangle from that. And that has an area of 8. Okay, so if we add all these up, we have an approximation of 15 using LRAM and 4 subintervals. Alrighty? Okay, so we've done RRAM and LRAM. The next one's going to be MRAM, so the midpoint rectangular approximation method. We are still going to use 4 rectangles, and I'm going to assume that they each have a base of 2. All right, now this time you want to take the middle y value, okay, not to be confused with the average. So if I look at that first subinterval from 0 to 2, the middle x value is 1. When x is 1, y is 2. So I'm going to make my height be 2, and then I'm going to come down and finish off that rectangle there. Okay, so for this rectangle, my area is 4. Okay, the next rectangle goes from x equals 2 to 4. The midpoint of that subinterval is 3. F of 3 is 2 again. So I have a height of 2 and a base of 2 as well. That's 4 there. Okay, that third rectangle, midpoint is x equals 5. F of 5 is 3. And then that fourth rectangle, the midpoint is 7, and f of 7 is 3 as well. I should have put 6 for both of those here. So now you are going to add all those up, and whoops, we get 20 there. So this gives us MRAM with 4 rectangles. Okay, and by the way, oftentimes, you may have seen it when we were on that application, but n is typically used as your number of rectangles, or really number of subintervals. Okay, all right, so our last kind of approximation method is the trapezoidal approximation, and let's go ahead and review how to find area of a trapezoid first, okay? So let's take a specific example. Let's say this is 2, this is 4, let's say that's 6, okay? So here's my trapezoid. Now take a look at this. Let me make a rectangle. And first draw this. So that is going to be right in between 4 and 6. Do you agree? That dotted line should have a length of what? Should have a length of 5. Now if I create a rectangle, it's still with that base 2, but now with the height of 5. Okay, so if that's my rectangle, do you see how that rectangle of base 2, height 5 has the same area as the first trapezoid there? Because this piece fits right into that empty space, right? So this area is going to be 2 times 5. And how did we get 5? Well, we averaged 4 and 6. Correct? Okay, so let's generalize what we just did. Okay, so instead of putting numbers to it all, let's put letters. And I do not use the same letters as a geometry textbook does, because I still like to think of this in terms of base and height, because your base is typically going to be in the x direction. Okay, your subinterval is going to be part of the x-axis. All right, so if I still call this base, let's call this height 1 and height 2, your area, you can still think of it as base times height, but your height, how did we find this 5 again? Remember, we averaged 4 and 6, so the height will be the average of your two y values this time. Okay, so instead of taking the left y value or the right y value or the middle y value, you're going to average your left and your right y value for each subinterval. Okay, now this will not always, in fact, most of the time, it will not be the same as averaging your LRAM and your RRAM. Okay, so just be careful with that. All right, let's try that same example. Let's still do 4 subintervals of equal length, but this time we're going to use the trapezoidal rule. I'm going to copy that here again. So just as a quick reminder, we'll have base times the average of the two heights. So still base times height, but you really want to think average when you see trapezoidal rule. Okay. So let's mark off our subintervals, still 0 to 2, 2 to 4, 4 to 6, 6 to 8. So to draw a trapezoid, you are going to take, oh dear, the left endpoint and the right endpoint, connect them, and then drop down to the x-axis. Okay? You'll notice this one is a triangle, right? Because your height, that first height there is 0, but we can still apply our formula. So base of 2, and then the height, I'm going to average this y value and this y value. So 0 plus 2.5 over 2 would give me that average, right? Okay, let's take a look at the second subinterval, 2 to 4. So left y value, right y value, connect them, drop down. So base is still 2, right? We went from 2 to 4, and then I want to multiply by the height, which will be the average of 2.5 and 1. Okay, next subinterval goes from 4 to 6, so left y value is 1, right y value is 4. Connect. You see what a good approximation method this is, even just using 4 subintervals? So base times the average of 1 and 4. Left y value, right y value, connect, drop down. So base times the average of 4 and 1. Okay, notice in this case our base was the same 2 each time, so I could have factored that out. In this case, this particular case, you get this nice cancellation, right? Okay, so if you add all of those up, you should get 16. Okay, all right. So those are our 4 rules. I want to show you typically how these look like on an AP exam. So these are, you will for sure, if you take AP Calc next year, you'll see these most likely both on the multiple choice section and the FRQ section of the AP exam. So how it looks like on the AP exam is same type of wording, but instead of giving you a graph, they give this to you as a table, okay? So let's take a look at this table. In fact, if you could please pause your screen and copy the table, that would be great. All right, so let's take a look at our x-axis first. So here's our x, and notice it's going from -1 to 3, all right? And part 1 of this question asks us to use RAM and 4 subintervals. So you know how we marked off our subintervals over here each time? We went 0 to 2, 2 to 4, 4 to 6, 6 to 8. We want to do the same thing here, again, using our x values because we want to be on the x-axis to mark our subintervals. So notice I'm going from x equals -1 to 3. So that's a length of 4. So if I want 4 subintervals of equal length, each subinterval should have a length of what? Of 1, okay? So let's go -1 to 0. That's a base or a length of 1. The next one is going to go from 0 to 1. That's another base or a length of 1. Next one goes from 1 to 2. And the last one goes from 2 to 3. Okay, so I really like marking these off and also putting what the length is because they're not always 1. They're not always the same thing. So it's really helpful to indicate the length of your bases there. Okay. All right, now the heights will depend on the method. So question 1 asks us to use RAM. Okay, so I already know for my first rectangle, I have a base of 1. And then the height will be the right endpoint. So look, here's your left, here's your right, here's your middle. Okay, so for RAM, I would want to use that y value. Okay, plus, here's my second rectangle. It has a base of 1. Go to your right y value, height of 5. Plus, again, base of 1. Right y value is 8, then plus base of 1, height of 13. Okay, and you add all those up, you're going to get 30. Alrighty, all right, let's try the same thing using LRAM. So same base is still 1 for each of these because I'm still using 4 subintervals. This time, I want to use the left y value for the height. So first rectangle will have an area of 1 times 5. Second rectangle will have an area of 1 times 4. Third rectangle will have an area of 1 times 5. And the final rectangle will have an area of 1 times 8. And if you add all those up, should get 22 there. Okay, be really careful with LRAM because what I see is students will then like to put in 13 as well. So a good check is just to count, hey, how many rectangles do I have? 1, 2, 3, 4. Yes, we're good. Okay. All right. Let's do MRAM now. Okay, so let's come MRAM, 4 subintervals still, so I like how we've got the x-axis marked off. We're going to keep that. Now we're going to use the middle y value. So first rectangle, base of 1, but this time a height of 4.25. Plus second rectangle, base of 1, height of 4.25 again. Third rectangle, base of 1, height of 6.25, and fourth and final rectangle, still base of 1, height of 10.25. Add those up, you'll get 25. All right, so now trapezoid. Remember with trapezoid, I want you to think, do you remember what word? Average, okay? So for trapezoid, we want you average your left y value and your right y value to get your new height, okay? Base stays the same. For this one, base is still 1, but now your height's going to be the average of 5 and 4. These are, in calc, almost always calculator active, or you just leave your answer unsimplified, okay? So please, please, even if your My Math Lab says don't use a calculator, feel free to use a calculator. That said, you do not have My Math Lab over this particular assignment, but you will see some for your review. Okay, so base of 1, height's the average of 4 and 5. Base of 1, now we're going to average 5 and 8. And then finally, base of 1, now we're going to average 8 and 13. And use a calculator. Alrighty? Okay, so that is how we approximate area under the curve. Again, you'll learn how to find the exact area next year in calc, and you'll also see more of the motivation about why in the world do we care so much about area under the curve. But for now, we really want you to get comfortable with these approximation methods because they do pop up a lot in our integration section. Okay? All right, so you have a worksheet on Canvas with this, very similar to what we just did. I believe that third problem, so you have a problem with the graphs given, a problem with the tables given, and the third problem it's given algebraically, so like f of x equals some equation. Just go ahead and make your own table there, either via Desmos or your own graphing calculator, and then do it the same way we've been doing it. You also have a key posted, so this will be a completion grade. Please turn it into your teacher by Thursday at 9 p.m., and we will talk to you all soon. Have a great day.